Hi, so the topic of this video will be vectors. So, you know vectors in 2D, they had two components, an x component and a y component. Now vectors in 3D have three components. They have an x component, a y component, and a z component. And vectors in 2D and 3D work the same way as vectors in 2D in terms of addition and scaling. So let's have a quick example. Let's say we had vector v with components 1, 1, and 1. We had vector u with components 2, 0, and negative 1. So if I want to do v plus u, I would have to add each component together. So I get 3, because 1 plus 2 is 3, 1 plus 0 is 1, 1 plus negative 1 is 0. Can also do subtraction. We get 1 minus 2 is negative 1, 1 minus 0 is 1, and 1 minus negative 1 is just 2. Can also do scaling. Multiply vector v times 5, you would get 5, 5, 5. Okay, so let me show you graphically what does adding vectors mean. So let's say I have a vector v here, it's vector v, and I have vector u, and I want to add them together. And the way this works is that you go from tip to tail. So if I want to have v plus u, I go from the tip of vector v to its tail, then from the tip of vector u to its tail. That's v plus u. That's one way to do it. The other way is by drawing a parallelogram. So let's say this is vector v, this is vector u. I wanna do v plus u, so you complete the parallelogram, and the resultant vector will be the diagonal of the parallelogram. So that's v plus u. And you should see they are equivalent. Can also do subtraction. So let's say this is vector v and this is vector u, and we want to do v minus u, which is the same as negative u plus v. So I will go in the negative direction for vector u. I go from tail to tip, then plus v, so I go from tip to tail. So this is my start point and this is my end point, and this is v minus u, which is the same as this. Now to find the magnitude of a vector, how to find magnitude of a vector, and the way we represent the magnitude of a vector is by adding the absolute value here. So let's say we have vector v as components a, b, and c. So if we want to find the magnitude of vector v, we have square root of first component squared plus second component squared plus the third component squared. So that's the general formula. Next thing I want to talk about is unit vectors. And unit vectors are vectors that have magnitude of 1. Their magnitude is equal 1. And the way we represent unit vectors is, instead of having an arrow, we have a hat. So like this will be a vector, this will be a unit vector. So an example of a unit vector will be this vector over here, 1 over square root 3, 1 over square root 3, and 1 over square root 3. So let's double check and make sure it's a unit vector. So if we take the magnitude of this vector, it should be equivalent to 1. So let's see this. So I take the square root of the first component squared, so plus the second component squared, which is going to be 1 over 3, plus the third component squared, which is also going to be 1 over 3. And so we're going to have the square root of 3 over 3, which is the square root of 1, which is equal to 1. So that's a unit vector. So if you are given a vector and you want to find the unit vector, well, you just divide it by its magnitude. So in this case, you just divide the vector by its magnitude, then you'll have a unit vector. There are some special unit vectors that we need to know. First one is I, which has the components 1, 0, 0. Second one is J, which has components 0, 1, and 0. Last one is K, which has the components 0, 0, and 1. And let me show you how they look like. So if this is the three-dimensional plane, this will be I. It has a magnitude of 1 and points in the x direction, positive x direction. This will be J, and this will be K. Okay. Last thing I want to talk about in this video is I want to write down some of the properties of vectors. So some of the properties that you need to know, and you can prove all of them. I'm not going to prove any of them, but they all should make sense to you. So u plus v is equal to v plus u. Just have a star. If you have a vector u and add 0 to it, you should get u. If you multiply 1 by a vector, which means you're scaling a vector by 1, you should get the same vector, u. If you have a scalar multiplied by a scalar times a vector, that's the same thing as this. You can take the scalar out of the bracket. And I think the last one is if you have a scalar outside the bracket of two vectors like this, you can just distribute the scalar on both vectors. So it's a times v plus a times u. I guess that's it. If you have any questions, leave them down in the comment section below, and I'll be more than happy to answer them. Good luck.